Guys, welcome to my channel studyhub. Today I will discuss about the chapter 8 of class 11, the redox reactions. I inform you that after the detailed explanations of this chapter, the important notes will be given in the description box. You'll go and check it. So let's start. See, redox reaction. From the name given, redox. Red means reduction, ox means oxidation. That means where reduction and oxidation take place simultaneously. So before going through this, the redox reactions, I am giving a little explanations about oxidation and reductions. The classical concept, I hope all of you know. So most probably I will give a little explanation. What is reduction, what is oxidation, and why it is called redox reactions. Okay, so what is the traditional explanations of oxidation? Oxidation is that what? So oxidation is what? First, what you know, the addition of oxygen. That is in a reaction where oxygen is being added, in a reaction where oxygen is being added, or first addition of oxygen to an element. Addition of oxygen. Number two, addition of not only oxygen but also oxygen related electronegative elements. Addition of electronegative elements. Number three, addition of electronegative, addition of oxygen, and opposite removal of hydrogen from an element, removal of hydrogen, or removal of electropositive elements, or removal of electropositive elements. These are the concepts of oxidation, and the reverse is known as the reduction. Reduction, I will not write all these things. Addition of hydrogen, addition of electropositive elements, removal of oxygen, and removal of electronegative elements. Okay, so the opposite of the oxidation is the reduction. So I will give quickly the examples of each and every results. Such example. What is that? So addition of oxygen. Most of the reactions, all of you know from class 6, 7, 8, 9, 10, you are reading this. Addition of oxygen. Suppose Mg is the metal. With this metal, oxygen is added. It is formed 2MgO. To 2Mg plus O2 twice MgO. So with Mg, oxygen is added. So this reaction is known as oxidation reaction. Suppose removal of electronegative elements means sodium K2 sodium Na2 sodium ferrocyanide or potassium ferrocyanide, whatever you can take it, with reacted with H2O2, hydrogen peroxide, to Na FeCN6 Okay, to K potassium ferrocyanide, K4 efficient 6, anything, K4 efficient 6, potassium ferrocyanide. Suppose K4 FeCN whole 6. This is known as potassium ferrocyanide. It reacts with H2O2. Then what will be the product? That is the removal of electropositive element. That is potassium will be removed out here. Okay. Suppose it is 2K. If you branch it, then 2K3 FeCN whole 6 plus twice KOH. That means 4 to the 8, 3 to the 6, 2K is eliminated, 2KOH, it is product. Okay. So K4 FeCN whole 6 plus H2O2 to K3 FeCN whole 6 plus 2KOH. Here electropositive elements is removed. So this reaction is known as oxidation reactions. Okay, oxidation reactions. Then same thing, the reduction, oxidation and reduction. Opposite, so many reactions are there in case of reduction. Suppose C2H4 plus H2, CH3, CH3, C2H6. In this case, hydrogen is added. C2H4, that is C2H2, CH2 double bond CH2. Here hydrogen is added, C2H6. Okay, C2H6. Hydrogen is added out there. So this is the process known as reduction. Hydrogen is added, oxygen is removed. So many reactions are there. I will not discuss about this. This is very mere thing. So you will go through the book and it will be clear. It is very easy from 6, 7, 8, 9, 10 onwards. You go through. We have already known to you. Next, that means if you take the reactions, the redox reactions, that means reduction and oxidation take place simultaneously. Reduction and oxidation take place simultaneously. Any reactions, if you go through, give an example where reduction and oxidation take place simultaneously. So many reactions are there, class 9 and 10. I will not discuss out there. I will discuss a little bit upper system in case of electronic concept theory, the electronic transfer theory. On the basis of the concept of electron, what is the definition of oxidation and reduction also? So redox reaction, all the reactions, most of your addition, substitution reactions, addition reactions, decomposition reactions, whatever you have learned, all the reactions are redox reactions. So I will not discuss this time now. Some exception I also discuss. I will discuss now on the basis of the electronic transfer, the concept of electron. What is the definition of oxidation and reductions? The loss of electron is known as oxidation and gain of electron is known as reduction. When an element or atom lost electron, it is said to be the oxidation. When an atom or element gain electron, suppose Leo, loss of electron, Leo the lion, there, remember it, loss of electron is known as oxidation. Loss of electron is known as oxidation. Loss of electron, this is oxidation. Gain of electron, reduction. So Leisure, loss of electron, oxidation, gain of electron, reduction. So any atoms or elements who lost electrons, suppose sodium lost one electron, it form Na plus. So what is this? It is example of loss of electron means oxidation. It is example of oxidation. Okay. Whereas chlorine chlorine, he accept gain electron. Chlorine accept electron. Yes, Cl minus. It is the gain of electron reduction. This process is known as reduction. Clear? Suppose Sn plus plus, then Sn plus plus plus, plus 3. So what is this by Sn plus 4? Sn plus 4. So 4 plus. So what is this? It's oxidation or reduction. Sn2 plus, Sn4 plus, Sn oxidized. It is oxidation or reduction. Loss on again. Sn2 to Sn4. Loss of electron. That means it is oxidation. It is oxidation. Loss of electron. It is oxidation. Then that is Sn oxidation means oxidized. Oxidation means oxidation. Loss of electron. Loss of electron. It is Sn oxidized to Sn4. On the other hand, Fe plus 3 to Fe2 plus. Gain of electron. Fe3 gaining electron, gaining electron to Fe2 plus. That is gain of electron means reduction. That means Fe3 is reduced to Fe2. Reduced to Fe2. Sn plus 2 oxidized to Sn plus 4. So it is oxidation, it is reduction. Clear? Okay. Now, it is a concept of electron transfer. On the basis of the electronic concept, what is the definition of oxidation and reduction? On the basis of the electronic concept, it is a oxidation and reduction I have discussed. Okay, I have discussed. On the basis of electronic concept. On the basis of hydrogen concept, electronegative element concept, electropositive element concept, oxygen concept I have discussed. Now, what is the oxidizing agent and what is the reducing agent? Oxidizing agent or reducing agent. What we see out here, electron loss, electron gain. Loss means donor. Loss means donate করছে, donor. Donor. Suppose D. Donor. Gain of electron. Gain of electron, that means acceptor. Acceptor. Donor, acceptor. A. These are the two, okay, elements. And elements D, other elements A. This element D donate electrons. These elements D donate electrons to A. Or this accepts the electron from D. It donates or it accepts. That means these donates. Donor. This is a donor. That is the lose electron. The loss করছে. What is the loss? These are loss of electron, oxidation. The loss means donor. That is the this is the donor. That is oxidized. That is the reducing agent. Reducing agent. Reducing agent. That it is a reducing agent. So this will be the oxidizing agent. Oxidizing agent, clear? That means donor of electron. The oxidizing agent, how do you say? Oxidizing agent is the acceptor of electron is the oxidizing agent, and donor of the electron is the reducing agent. Clear? That means suppose I am given an example. Na plus Cl from NaCl, Na plus Cl minus. तो Na plus Cl Na से NaCl कैसे होता है? इलेक्ट्रॉन लॉस करने के बाद लॉस ऑफ इलेक्ट्रॉन, दैट इज दिस इज द डोनर. एंड Cl से Cl माइनस कैसे होता है? एक्सेप्टर. तो Cl इज द एक्सेप्टर. Clear? So it is the donor, it is the acceptor. Donor means reducing agent, Cl means oxidizing agent. Okay? So what is oxidizing agent? What is reducing agent? Who is oxidized? Who is reduced? Clear? Okay? So next item. Yes, it is very not so hard. So don't be confused because it is very easy. Bachcho, just try to grasp the meaning. Try to grasp. Just idea, concept, idea. Concept, take the idea, take the concept and go through the books and go through my lectures. Go to my description box. All our descriptions are given there. Subscribe it, like it, share it. Okay? So it will be helpful for you and also to the others, to your friends also. So now, in this case, you have to know about something about the competitive electron transfer. Competitive electron transfer. Okay? Competitive electron transfer. Okay? So, what is electrochemical series? When elements or ions are arranged in their decreasing or electron losing property or increasing order or electron gaining property, this series is known as electrochemical series. In electrochemical series are sodium, lithium, potassium, beryllium, strontium, calcium, sodium, etc. That means this is greater than this is greater than this. This is the electrochemical series. As for example, when you suppose this is intermediate and this is the solution. This is the copper nitrate solution. Copper nitrate solution, a zinc rod. Zinc rod is kept out here. This is the copper nitrate solution. Zinc rod is kept out there. So what will happen? What will happen out there? This is the solution, its color is blue. After some time, what you will see, this is the intermediate state. Intermediate state. And this is the final state. Final state. That is the light bright color. No, white light color. And colorless. That is the colorless. It is blue. It is light blue. Why it is happened? What happens? This is a zinc rod. This is zinc rod. Okay. Where out this what is this out there? Here copper nitrate solutions, it will dissociate copper ion. This is zinc rod. These copper ions, copper 2 ions and zinc, what will happen? That is zinc, Zn plus, Zn2, Zn plus. How it happens? That is, it lost electron. If it lost 2 electron, so Zn plus plus, then copper plus 2, it will accept electron. It will accept 2 electron, and it will be copper, and this copper will be deposited on this zinc rod. Then the color will be disappear. Blue color will disappear because copper taking electrons, copper will be deposited at the zinc rods. Why copper? That means zinc displaces copper. Out here, copper is there. Okay, zinc is out here. Zinc is out here. I'm not written. Zinc is out here. The copper zinc displaces copper. That's why out zinc rod copper will be deposited at this rod. But in case if you put, if you this is the solution, what is this? Zinc solution, any zinc solution, okay, Zn solution, zinc solution you are taken. Here if you give copper rod, then what will happen? This is copper rod. What will happen? Is there any change or not? Is there any change or not? This is copper rod. Copper silver out there is greater, it is in lower position in activity series, so there will be no reaction, copper and zinc. Copper and zinc do not react because in this the metal activity series, okay. But if you put there silver nitrate solution, copper silver, silver nitrate, copper silver gold, silver nitrate solution, if you give out here, then it will displace easily. If it is silver solution, it will be easily displaced because copper plus Ag plus will form the copper plus Ag. It will what will product Cu plus 2 plus Cu plus Cu. Cu से Cu2 plus कब होता है? Cu means atomic stage. When you lost electron, it will be Cu2 plus, and in that case Ag plus taking electron, it will be 2Ag. Solid Ag will be deposited. So in case of silver solution, copper rod is there, so it will be reaction will take place. Then copper plus silver, copper 2 plus and silver. This is the okay. So next day I will discuss the oxidation number. Okay. So this is the, here I draw my ends.